Okay, so welcome back, everybody. What I quickly want to start off today is just find out if anybody had any questions from the last session that they may have thought about from the last session to now. So I'll quickly open that up for a minute. Seeing that nobody's jumped in, I'm assuming there's no questions. And I'm going to share my screen. Okay. So very quickly, I'm going to start off with a quick refresh of some of the quick and some of the highlight points from the first session. First one revolves around color itself. So what it actually means when we talk about color. So the fact that as human beings, all that we can do is perceive it. We can't measure it. We can't associate it with anything. The fact that for color to exist, you need a light source, the object, and an observer. If there's no observer, is there a point to the color? Similarly, if the light source is turned off, like you turn the lights off, is there a point to the object having color? If you can't see it because there's no light, there's no point. So this highlights why we look at going into instrumentation for color and process control, because we have an uncontrolled light source illuminating an object. We have an uncontrolled observer perceiving that object, which means the one thing we want to see is potentially if the object is changing color. But if two of the controlling factors are changing as well, then the likelihood of us being able to perceive a change in color of the object is very low. Next thing we spoke about were some of the fundamentals on human eye and some of the issues that we do face. So the effects of background effects on color, our poor color memory as human beings, color deficiencies, so color blindness, lighting, the effect of lighting condition on color, changing lighting conditions. And it's not being discriminatory, it's stating a fact, the age and sex of the person viewing the color has a direct impact on both the color itself as well as the likelihood of that color being observed. And then as human beings, our inability to record that color. We touched on LAB color space. So what it means when we actually do measure a color, how do we communicate that color? And being able to take that color and plot it into a three-dimensional color space then makes it much easier for us to communicate that color to others. How do we express the difference between two colors is via color difference or delta E. We discussed the different color spacing models, what delta L means, what delta A means, what delta B means, so that we can start to get a feel for when we talk about a change in color, what does it actually mean? So they're the highlights. We did go into understanding density, the controls around density, and some of the other factors around process control, including some of the print standards that are available. Today's session, we're going to really focus down on those process controls that you need to start to get better performance from your printing press, as well as your process. A fair bit of what we will do today will be relative to G7. It does not mean that you need to do G7 to make it for this to have an impact. Adopting some of these processes will definitely have an impact and will enable you to get better control over your process. Okay, so we'll start with understanding some of your press room variables. Having the proper tools and daily maintenance to measure your variables, making sure your press is running to the manufacturer's specification, ensure that your incoming raw materials are either becoming pre-specified or you're measuring and verifying them. Understanding what your ink on paper process control is. What are you doing? What are you measuring? And how are you doing that? Understanding where there's a possibility for operator error to occur and how you can reduce that both with handheld systems as well as potentially automated instrumentation. And then lastly, good record keeping. There's no point in actually doing all of the above if you're not actually storing it as a record. So if you're not actually keeping that data and having that ability to go back and question that data later, the real question comes down to, why am I doing what I'm doing? Okay. So starting off with press manufacturer specs, understanding what they are, reading a manual, understanding from your press manufacturer what their targeted specifications are. That's really all that I need to talk about. Press room tools for offset, quite important. So color bars. I understand that they're not always possible to print them. Where possible, however, it is highly recommended that you print color bars so that you have an independent way of measuring them out of your print to give you a standardized process for measurement. Having a densitometer for measuring density or dot and color, or a spectrophotometer for doing that. Thickness gauges for measuring how thick are you actually printing material. And then a durometer for measuring the hardness of the surface that you're actually printing. Other tools, pH, if you're printing water-based as opposed to UV, pH and conductivity meters for measuring your pH of your water and the purity and dissolved solids in your water. A gloss meter for measuring, once again, the gloss of the product. If you're printing it with a matte varnish, you want to ensure that the matte varnish is actually coming out matte. If you're printing with a gloss varnish, you want to ensure that you're not having an interaction taking place between your varnish and your ink. And then a blanket packing gauge. Okay. When we go to Flexo, some of it's the same, some of it's slightly different. So once again, color bars, highly recommended. In Flexo, you will tend to also print registration marks. You'll also print those in offset and litho. Definitely recommended to ensure that you're getting print alignment through your job. And then once again, a densitometer, spectrophotometer for measuring density, dot, and color. Press room tools. Some of this is similar to what we had before: thickness gauges, durometers, gloss meters. Press testing is a little bit different. So for Flexo, when we're looking at the variables within our press to controlling our drying performance and press temperatures, registration control, web tension is a big thing. The gear condition to control web tension, parallelism, making sure that your ink is printing uniformly across your web, and roller and cylinder balance and wear, which then leads to defection. Because without that roller cylinder control, trying to get consistent film thickness is difficult. Set up variables, measuring your analoxus, mounting tape, locking in your plate type, measuring your ink, coating, and substrates. These are all the variables that you're going to have within your process that you need to analyze and work out, how do I control that? In Flexo, complete these. It's highly recommended you to look at measuring dot bridging, your hard edges, maximum density that's being in your proper print contrast, vignette smoothing where you actually have your your dot transitioning, measuring your solid colors, checking them for pinholing, ghosting, and mottling, so that your ink is solid. And even the impression of across the cylinder is highly recommended to ensure that you're getting a constant film thickness across the cylinder. A lot of this is the same for litho. It's just slightly different terms that we use. Okay, plate curves. So with G7, this is part of what we would normally do with G7 is going through and doing plate curves. It's recommended you understand how your plate performs. Okay, because if you don't know how your plate performs and you don't know what your dot gain curve on your plate is, then you're going to have an issue with your TDI or your dot gain on your press. So run the calibration run. Once you've done that, measure your solid ink densities to generate your plate curves, and then verify those curves and ensure that you've got those curves under control and ensure that you've got them going through your plate setter correctly. If you can, highly recommended to run a fingerprint. And that can save you a lot of time in the back run. And then finally, you'll be a P2P and then build an ICC profile of your press. Important of that ICC profile, that can be used within your pre-press to do a press simulation. It's also used within your plate side for your plate curves. Okay. Next important thing to think about controlling is ink. A lot of people within the printing industry take it as a given that the ink supplied to them is correct. Just take it as a given. The ink that I'm getting is correct. The ink you're getting is correct at a targeted density. Okay, so if we go back to last week when we're talking about printing ink color, it's transparent. So you're getting white from substrate. So the color being supplied to you of your CMYK inks or your spot color inks are correct at a targeted density. If you don't know what that density is, trying to achieve that color on press is almost impossible. If anything, it's going to be a very hit and miss process. Okay, so asking your vendor for a C of A, validating that this color is correct against the standard that's applied. But it should be a delta E match of less than 1 against the standard supplied at a targeted density, so that if they give you that density value, you know to target that density. Achieving that density will achieve that color on paper. Okay. Conversely, you can measure the ink yourself at the proper ink film thickness. If you've got a hand proof or if you've got a K proofer, proof the ink yourself and measure it and validate that the ink is correct. Okay. Also then looking at the ink tack and the water pickup of the ink. Okay. So what do you need? Okay. If you simplify it down, if you don't have a spectrophotometer and you're dealing with Pantone colors, for example, making sure you're using the latest Pantone formula guide is a good start. Not using a guide that's 15 years old or 20 years old. Okay. Also understanding that this says formula guide. This is not a color standard. This is a guidebook. So there will be variation in books. Okay. Conversely, what is the difference between, does anybody know the difference between the Pantone color bridge and the formula guide? Can I have someone answer?
Color bridge is mainly the color combination alternative to Pantone?
Not alternative to Pantone. What it is, so if you look at
closest color you can get by
yes, that's it exactly. So it's the closest process color you can achieve to a PMS spot color. So what you see here is Pantone 1767 on the left with the Pantone formula. On the right, you see Pantone 1767, and then next to it, you see Pantone 1767 PC. And then you see the CMYK breakdown. So that's the nearest color that you can achieve doing it in CMYK. Okay. So if you're bridging between spot and CMYK, very easy to do. You can do the bridge. And that'll give you an indication of how far the two are away from each other. As far as measurement of ink, if you want to proof ink, you need to understand what is the ink film thickness that this ink was actually formulated to. What is the targeted density? So you need to talk to your ink supplier about that. Okay. You also need to understand the measurement conditions around the color measurement that the ink supplier did. So you need to ask, what was the illumination? What was the observer angle? What was the instrument that was used to measure this color? And thirdly, what was the delta E calculation used? From that, you can then set those settings within your device, produce the ink to the density that they supplied you to it at, and then check the color. Does that match the color that I sent them? Okay. Conversely, we do sell a product called ink formulation software, which takes the guesswork out of doing ink color matching. So if you're doing ink formulation on your site, or you're looking to use away ink leftovers, we do have tools that can help you to achieve that. Okay. The next one is something quite new to Australia, and we are starting to see more pickup of this. So the color bridge is CMYK bridge to the Pantone color space. The PMS book is the PMS book printed onto white paper. But what if you're not printing onto white paper? What if you're printing PMS, but you're printing PMS onto carton recycled board? Brown craft. You can't print the PMS book onto brown craft. It doesn't happen because brown craft is brown. Pantone Live is the answer that we've created. So the Pantone Live library system is a cloud-based library system. At the moment, it's roughly 50 libraries, whereas the PMS guidebook bridged by application and substrate for the next achievable color. So for example, you could go onto the Pantone Live library and do a color replacement to go from the PMS book to PMS 1767, surface print, reverse print white onto clear poly, or surface print clear poly, surface print virgin carton board. All of these, as you can see, one would save litho, one will save flexo. So the process, how it's produced, is also taken into account. So it would be flexo, surface print, clear film, white back. All of the substrates that we use are defined by the ISO standard, and they're specified as part of that library system. So the whole point of this is to give you an ability as far up the supply chain as possible to bridge to an achievable color space for your process. Okay. So the next thing, paper. Importantly, paper is a color too. Okay, it's not just what you print on. It contributes directly to the color that you're printing. Okay? So understanding the LAB of your substrate is important. Understanding the white point of your substrate is important. The image on the right shows you the effect that substrate has on the same color ink. So if you've told your ink supplier that you're going to print onto virgin white paper, and you're actually going to print onto recycled white paper, you may see the difference between those first two samples. Virgin white being the second sample, recycled white being the one on the left. So suddenly the change in color on press is not because of the ink, it's because of the substrate. So understanding when you specify color to your ink supplier, you also should be telling them or giving them a sample of the substrate that you want them to produce the ink onto. Because once again, this has a direct impact on the color of what you're going to produce. The interesting point here is making sure that your proof, when you print a proof, it's been proofed to simulate your press conditions, which includes your substrate. Are you printing a white point compensated proof? Okay. So once again, looking at color, paper, to give you an idea of the differences that it has in the grey coal, the white is at 95, 0, and then -2. For swap, 93, 0, 0, and then swap paper type 5 is 90, 0, 4. So these are differences, and they're quite significant differences in the paper types that are used within the different standards. So understanding your paper and understanding where your paper fits within your process becomes important. Okay. So print run control. Once you've actually gone through your press setup and you've got your press setup correct, you've got your ink under control, you've got your paper under control, what should you do in your process run? So at the start of every run, you should be checking your plates. Number one, check my plates. Are my plates correct? Okay. Number two, measure your solid ink density as well as your solid ink colors. Measure your dot gain or TVI. Measure gray balance. Make sure that what you're producing through your plate and on your paper is correct for density, correct for color, correct for dot gain, correct for gray balance. And then depending on how you're printing, you may also then want to look at potentially measuring the overprint and trapping. So that's when you're printing yellow over cyan to produce green. Okay, or blue over magenta to produce purple. Okay, so that would be G7. Non-G7 measurable processes. Once again, you can measure solid ink, measure TVI, gray balance. Dot gain, you would want to keep as close to your historical values as you can. And then depending on how you want to control your neutrality, you could print your gray balance and then adjust your gray balance to maintain neutrality. Okay. For G7, once again, very similar processes. Gray balance is the most important thing to measure. Then you measure your dot gain, then you measure your solid ink. Okay. Then during your run, you need to continue to measure during a run. This is not just an upfront measurement process. Once your press is running, as it heats up, as the day heats up, as the day cools down, as the ambient temperature changes, all of these things will have a direct impact on the performance of the press. And you will need to make fine-tuned adjustments through the day to ensure that your press is working to its optimum. Okay. So when we're looking at solid ink density or SID, okay, how does that affect it? Okay, so if my color inks are the correct color, but I'm printing at the wrong density. This is an example of what it would look like. So you want it to look like the top, but it's actually printing out and looking like the bottom. It's not, it's looking washed out. The colors, the overall color looks correct, but it doesn't, it just looks lighter than it should. Okay. So once again, measuring your densities. So in this instance, these are exactly the same densities that have been measured, but the colors are incorrect. Okay, this is where it gets really interesting. If the colors are incorrect, but the densities are correct, something's happening that's wrong. And in this instance, if you look at it, it's our gray balance. It's our 50-40-40. Cyan, magenta, and yellow is out. Okay. So the inks do not match. So if you check the color measurement, the color measurement's out. Okay. So measuring your solid ink densities is one thing. Solid ink density is process control. It allows you to control your press and make adjustments to your press. It doesn't tell you whether the product is actually the correct color. Okay. It can also tell you whether or not the press has picked up contamination. If you start measuring color, one of the first customers I saw going back now like 9 years when I started working in color was a printer. And we went out on site and they were printing CMYK. But the yellow ink that the operator had picked up to use in their job was contaminated. It was contaminated with a small amount of magenta, which meant that instead of printing yellow, he was printing an orangey yellow. Now, he was printing to the correct density, but his output color was, instead of being yellow, was orange. And he had his densitometer saying, look, it's at the right density, it's at the right density. And when I pulled out a spectrodensitometer and measured it and showed him, yeah, it's the right density, it's the wrong ink. Then he got back up in the ink duct and looked in the ink duct and said, oh shit, my ink's wrong. Okay, so density gives you part of the picture, not the whole picture. Even for CMYK, density gives you part of it, but density doesn't tell you if the ink's contaminated. Okay, so just giving you an idea of some of the solid ink references that are out there for different standards. So once again, under grey coal, using paper type 1 white backer, our LAB standards for our cyan are 54.96, 37.12, and 50. So we can actually input that into our device and then measure against it. Similarly, under swap 3, you see those values are different. And then under swap 5, those values are different again. Okay. So what do the numbers mean? So solid ink density reflects the amount of ink on paper. Okay. As the ink film thickness goes up, the density number will increase. As the film thickness goes down, the density number will fall as well. So if an operator sees that he needs to print a job at 1.3 density on yellow to get the color, and he's printing at 1.2, he can increase to 1.3 and he should see the color come up if he's printing CMYK. If he's printing spot color, then we use spot color density. It gives them a tool to measure and then make adjustments to their press to match historical print specifications. Okay. So using solid ink densities in conjunction with color measurements allows you to start to get a feel for adjustments color-wise that can be made to a job. So ISO and Ideal Alliance provide you with LAB target values for their CMYK values. Okay. We actually have those created as pre-job files, and you can download those from our website to upload into your device. So you can then just go to the compare tool, select the color you want to compare, and measure a sample, as in this example. And you can see that you've got a 7.32 delta E difference in color, which tells you straight away, okay, I've got a problem here. It's not within my acceptable range. Okay. One thing we do slightly differently to other devices in the marketplace, Retag Macbeth created a process called Best Match. We've now taken that and we've enhanced it further within our latest series of devices. Best Match is the link between color and density. Okay, so Best Match will not just tell you the difference between a standard and a sample by density or by color, it will actually tell you the best correction to make to density, or if it's in Inflexo, the concentrate or extender that you need to add to achieve the correct output color. Okay. So in this picture here, our standard is there, our sample is here. Best Match looks at the two and works out the best match between the two. So the best delta E and the adjustment required. So as you can see in the picture here, this is set up for Flexo Gravure. And it tells us that we're at 3.52. We can get to 1.36 by adjusting our concentration down by 0.24% or minus 16%, and we will get to 1.36 delta E. If that is an increase of 16%, then it will say to add more concentration. Okay. Conversely, this can also be set up to litho, where it will talk about the ink density adjustment. Okay. So this is giving you an indication. There's our reference on the left and our reference on the right. Our current delta E is 1.85. We can get to 0.33 by adjusting our concentration by our cyan by plus 0.17 in density. Okay. Before I move on, does anybody have any questions about Best Match or anything else that we've touched on so far? Okay, so let's move on. So how do I use SID and LAB numbers? Okay, you use them to adjust the density on press to targeted LAB values. We can use Best Match as a tool to enable us to do that. We can use basic compare to see the effect of those density adjustments. Okay. You can also establish your own in-house solid ink density targets. If the specified standards aren't applicable to you, you can create your own internally. Okay. So what do the numbers mean? What if I cannot get my solid ink density and my color values to match specifications? So what if I can't? Well, I've tried everything. I can't get my densities to the benchmark, and that means I can't match to that standard. You need to go back to our setup, and we need to confirm paper. We need to confirm that the inks are the correct inks, and we need to confirm that we're using the correct either extender or we're using the correct water balance. We're not doing anything to the ink that modifies it in a way that could help push it out of the process. Okay, so TVI or dot gain, as the old phrase was, is pretty much in everything that's produced. Dot is what gives us the tonal values within a print. Okay, what we're looking for is what's on the left. What we have at the top is the correct densities, but the dot gain is high. Below, we have the correct densities once again, but our dot gain now is low. Okay, so effectively in the one above, the density is correct, but we have too much ink on paper. The one on the bottom, we don't have enough ink on paper in our transition sections. And as you can see with this image, pretty much all of this image would be screened. Okay. So how much did your dot gain grow? It sounds funny. Typically, you would allow plus or minus 3% on dot gain. Okay. Now, if you're experiencing dot gain of greater than that, you are going to start to have an issue with your printed color. Okay. So in this instance here, our press sheet minus our plate, we're getting a 17% dot gain in our process. Okay, that's quite high. That means if I'm trying to print a 50% dot, I'm actually printing a 67% dot. So I'm printing 17% more ink than I should be. Okay. So there are two types of dot gain. Okay. First one is mechanical. And that's physically getting the dot and going squish and squishing it too far. So instead of the dot being a circle like that, your dot's a circle like that. Okay. Second one is optical. And this is dot gain that's due to light scattering or absorption of the substrate, which creates a shadow effect. Okay, so it's if you're looking at a cup and you shine light from the side of it, if it's giving you an extra shadow off the side, that's going to appear as optical dot gain. Okay, so this is an example of optical dot gain, where on the sides we have space where we can actually build a shadow. See here? You can build a shadow off that side. Okay. So giving you an idea of some of the historical TVI references for a white backer. Once again, depending on the standard that you're using will then dictate what your reference points are. Under G7, we don't just use one point. We'll use multiple dot gain points within our dot gain curve to build exactly what we see here, which is our dot gain curves. Okay. And once again, what does it mean? It means during make ready, before you measure TVI, you look at you start to calibrate your plates. making sure you're using calibrated plates to your process. Confirm your ink density values on your plate. Okay. And then looking, if you're using old school methods, you would look at historical specifications, or you would look to try to produce against an industry basemark dot gain curve. So like a G7 curve. And then you would make small adjustments to your TVI to try to ensure that you match either your historical curve or you try to match the standardized curve that you're looking for. Okay. Then with dot gain, what do the numbers mean? We're getting dot from somewhere, but we don't know where. We've checked our plate, and our plate's okay, or it appears to be okay. Go through and check the things that can be influencing dot gain. So, plate wear. Okay. Check our water, check our chemistry. Are we at the correct pH for what we're doing? Is our plate aging? Was our plate supplied to us correct in the first place? Check our blanket. Do we need to change the blankets on our press? Check our substrate. Are we using the right substrate? Are we using the right thickness substrate for our job? Check our plate and blanket connection. Check for oxidization of the process, your ink, slurring, picking. Check for all of these plate-related ink failure points that can have a direct impact on your dot gain. So, as I mentioned before, overprint and trapping, pretty straightforward when you're using process. It's one process color over the top of the other. Checking for the correct overprint can be quite important because when you're printing CMYK, the bulk of your non-process colors are overprint. Making sure that you're printing those to the correct densities are really quite critical for getting the correct overprint color. Okay. So showing you what trapping is. So you're measuring your cyan at 100%, your yellow, and then you measure your overprint green. Okay. Knowing your ink sequence on your press sounds fundamental because it is fundamental. It's important to know that process. Okay, because your jobs will be set up for that process. And if somebody changes the ink into the cyan tower and then the cyan into the yellow tower, your whole job's gonna be out. Okay. Once again, color bar. Trapping, we can only measure at the color bar because it's the only spot on the job where we'll actually have a controlled overprint of paper and ink. Everything else will be in the job. So picking a spot may vary by 4 or 5 delta E. So having a control point on the color bar is important. Okay. Once again, break, hold, and swap have target values, and they're traditionally looking at a delta E of less than 6. Some of the standards are quite literally large enough to drive buses through. Okay. Once again, those two supply overprint targets for your jobs. Okay. Once you've done that, measurement in production can be really quite fast. And once again, you can download the job file from Xwrite for this, where you go to the job tool, open up your job, and then it will be a pass or fail with one measurement. And if it fails, you go back to that 4-step process to try to work out where it's failing and why it's failing. Okay. And then controlling it. Okay. Confirming your solid ink densities. Ensure that your sequence is correct. making sure that your inks are correct. Changing ink properties can have an impact on this. Adjusting ink and water balance. Once again, your blankets and your substrate. And then what you're actually printing on, your substrate, period, have a direct impact on what you achieve via trapping or overprint. Okay. Gray balance. So for G7, this is the most important thing within G7. Within ISO, it's still measured. It's not as important in their process. Gray balance is ensuring the neutrality of your cyan, magenta, and yellow. Okay, making sure that those three overprint to produce a neutral gray is important, because you're not always going to use black to produce gray. Okay. So what you can see down the bottom of this print on this screen, on the left, a grey printed with cyan, magenta, and yellow. And on the right, a grey produced by printing black. Both of these are at the same dot. Okay, and they should measure pretty much the same. If they don't, you've got a problem. Okay, so how can you measure? Measuring with a spectrophotometer is one thing, and that will give you your LAB values in comparison against a standard. You can also measure density, and that will give you your CMYK or CMY values against your reference standard. Or you can use best match, which will do both. Okay, so once again, in the G7 job, we show you that's the gray balance tool. Okay, where you can measure a single sample and it will tell you what your gray balance is, whether it passes or fails. And then you can go to the graphical view and it will show you the density adjustments that you need to make to correct the gray balance. Okay, then once again, different standards have different reference points. If your adjustments for solid ink density do not correct the gray balance, then there's something significantly more wrong with your job. Okay. As you can see below, all of these prints were produced using exactly the same plate, but they have the same solid ink density values. Okay, same plate, same press, same ink. Okay, but we get different values. Either chemistry's been adjusted. We know that the density is correct because we're measuring the density. So in this instance, we would look at it and say, okay, substrate. Is substrate the same? Has the ink been modified in any way? Let's measure the color of all of the inks and ensure that the inks are correct. Okay. Check TVI. Do we have the correct dot gain? Okay. So then we have the real one. What if SID does not fix my gray balance? Confirm your solid ink density and color. Check your dot gain. Make sure you're using the correct paper for your job, the correct paper that you set up for your job. Okay. These are ideals if you're looking to do it. So your first point would be 50 cyan, 40 magenta, 40 yellow. And then your optionals would be a 25, 19, 19, 75, 66, 66. Okay. If you want to go beyond just a handheld densitometer doing this, you can go into press process control. So either your press may have a system supplied from your press manufacturer, like from Heidelberg or a Komori closed loop system, or as X-Rite, we do have a third-party system where we use an IntelliTrack scanning unit with a Rutherford closed loop system to then achieve the same function. Okay. I'm not going to help sit on this for very long, but this automates the process to basically turn that entire process that we've been going through here, where measurement of dot gain, trapping, color, are completed inside of around about 20 seconds. And the process is then automated within the software to then produce adjustments to press to ensure the press gets to color quickly. Okay. Giving you an indication of measurement of a press sheet. So what you see in the middle is your gray balance. Up the top, you see another gray balance. In the middle is our black. Then we have our second black and our gray balances. Okay. So measured the standard P2P 25 patch, which is this one over here on the right. I'm using an i1 Pro 2, Pro 3, i1 IO or an ISIS, or you can use an IntelliTrax for production. And using the correct curve software to plot your plate curves so that you have the ability to optimize your plate curve for your press. And then using those curves within your RIP so that when you're producing your proofs, they simulate the curve for your press. Okay. So does anybody have any questions? I think we're pretty much on time. We've got a bit of time for any questions that anybody may have. I know it's pretty content heavy, but what the purpose of this couple of series was to try to give a little bit more information back to the printing industry in Australia that I think has lost a fair bit of it over the last few years with COVID. A lot of people have transitioned out of the industry into other spaces. And from feedback from customers, they did see a need for a bit of education again. So depending on what people thought of this course, it may be something that we do again. And once again, if customers want to have a more in-depth discussion about their process, what do they need to do? How can we better help them? We're more than happy to have that conversation.
David,
Yes.
Shaker here. Look, we discussed about the Pantone base color and then the CMYK and the bridge book and Pantone book. How it work with this new technology, CRS technology just introduced, because we start having some issues there where when we are changing from Pantone based color to CRS based system, again it is the ink thing, but on press also there are some comment come from customer like ink is little bit weaker or it is different feel and all that kind of. So how we can able to narrow that gap?
A lot of that will come down to understanding and specifying the correct standard through the process. So if you're producing a color if your output color on press is not the color that's where the ink is being proofed, and even down onto the substrate that the ink's being proofed onto, and understanding the film weight that ink's supposed to be printed at when you're formulating the ink in the first place, are key things that you need to understand. So you need to know from the customer's perspective, how are we going to run this job? Are we going to run this on a 300 analogs, 200 analogs? Are we running this on a litho press? Are we printing, is it water-based ink or UV ink? Is it solvent-based? So, and then I'm really getting a sample of the substrate from the customer becomes another key component, because you need to know the white point that you're printing on. Even at an ink formulation perspective, you need to know what they're going to print that job on. There's no point in you proofing an ink in your lab on a Lanita black and white card if the production is going to go to a site who's then going to print it onto recycled paper. Those two substrates are not relative to each other. So your proofs in your lab need to be on the substrate that they're going to print that job on.
Yeah. Okay. Thanks.
Okay. Any other questions from anybody? Okay. If we've got no more questions, we're going to. This will be the end. So once again, the recording, Yasmin will send the link out to everybody if they want to view the recording. If anybody would like to have a chat about potentially what they can do within their own process to better control or try to achieve some additional savings within their process, once again, more than happy to have a chat with you. You can reach out to the guys at Ball and Doggett or reach out to myself. And we're more than happy to sit down and have a chat and understand your process, understand where you want to improve, and hopefully be able to provide you with some feedback regarding that improvement. Okay, so thank you very much, everyone, for attending, and we will have a great weekend, everybody.